So this is a short talk on web animations, something we've been working at Google in Sydney. To dive into the topic, I just want to give you guys an idea of what it's like for a web developer to create animations on the web currently. So the current technologies we have available are CSS Animations, SVG Animations, and JavaScript. Quite a powerful option there. You've got Canvas, WebGL, and just the full power of JavaScript at your disposal there. And then Flash, but Flash is sort of slowly becoming obsolete, and most websites are encouragingly moving away from Flash. So CSS Animations, the way you use it is you can either create transform animations to sort of pay attention to specific properties, such as here the transform property. If it changes, the transition will start an animation that continuously animates it from whatever it used to be to what it was set to just then. So if I just hover over this red square, we get an animation on transform, which is going from nothing to rotating 360 degrees. So we get that nice transition. And alternatively, we can set up a keyframe animation, setting various keyframes. It can be as many keyframes and as complicated as you like. This is a simple example where we're just doing the same thing. We're rotating. And so you can set these simple timing functions, durations, and whatever. So the next option, so just looking at that, it's very simple to set up. You just set these small properties and the web browser will animate things for you. It's also declarative, so you don't need to, you just declare, hey, I want to animate this property, and everything's done for you. You don't need to procedurally generate each frame or anything like that. And it's also not tied to the main thread, which means that these animations don't necessarily use up CPU time that would otherwise be used for UI purposes. So say if you're scrolling the page or something and you've got lots of animations on, they won't necessarily interfere if they're done on specific properties such as transform and opacity. These are things which can be done in a GPU process or something that doesn't require recalculations of CSS styling. And there are simple controls for just pausing an animation and resuming, but not too much in that department. Once you've set up these transitions or keyframe animations, you can't really modify them anymore. Your best option really is to just set another style element inside your DOM, which is horrible and hacky and not advised. And there's no primitives for synchronizing multiple animations playing together. Say you want to have one keyframe animation start and then another one start after that, or one start halfway through, or anything like that. You can't declare that sort of thing. You would need to do that manually in JavaScript, detect at what point in time you want the next one to start, and manually change the CSS properties such that the animation starts. And that's not so nice. That's not very declarative. And also you can't stack multiple animations on top of a single element. So if we go back to the spinner one, so how we set the animation to the spin keyframes, if there was another set of keyframes we wanted to also apply, we couldn't. You would have to create another set of keyframes that looks the combination of the two. And yeah, that's not very nice.
Okay, so another alternative available to web developers today is SVG. And here's a simple example. And so this is like completely separate from your HTML content. You just have some SVG elements and you can declaratively declare transforms on them. And you can have simple controls like pausing and resuming. And you can transform simple properties. Again, there are limitations. So the good thing is it's nice and declarative and like clear what you're aiming to do. We've got the playback controls. We can synchronize animations together, so that was an advantage over the CSS animations and transitions. But it's one big SVG animation. We don't have separate controls over different parts. We can't modify it, so it's basically a pre-canned animation. And it's not integrating with the HTML content, so it's like a completely separate. And this is some of the same disadvantages that you had with Flash in that sense. And not all browser implementations have support for SVG animations, which is a drawback for usage. For example, Internet Explorer doesn't have the SVG animations. And because it's not so widely used on the web, like browsers haven't put as much time into optimizing it, which means that you're not going to get the performance that you say hardware is capable of, which is disappointing.
And so the next alternative is to use JavaScript. And so as you can see in this example, we're just calling this function every single frame by using request animation frame. That just tells the browser, hey, just before the next frame, execute this, and then it will automatically do that clocked to 60 times per second. So you hopefully get a nice smooth animation, and then you can do whatever crazy stuff you want to do. You have total control here. So here we're just using a sine function on the time to set the rotate, like the rotate before, on the inline style of that object, the blue square. So because it's JavaScript, because it's programming, you can do whatever you like. And it's got access to much more than what CSS and SVG has. So that's the canvas, that's WebGL, that's whatever else JavaScript can bind itself into. And it's extremely portable because it is JavaScript. It doesn't require the browser to actually implement some API like SVG animations. You implement the API yourself. You implement all that yourself. And this sort of thing, because JavaScript is very portable, it's used beyond browsers like in Flash and other technologies. That same code can be used outside of the web. GreenSock is an example of that. It's both a web animation library and for Flash as well. But because it's so low level, it must run on the main threads. It can't be sort of, the animation procedure can't be put off into a separate thread to run asynchronously with the user interface, because of what JavaScript is capable of doing. There's no way to guarantee that there won't be weird side effects, or and it's completely procedural. You don't declare things up front. You don't tell the browser, this is what I want the animation to be, and let it work out, or let it actually process the animation part. You do everything yourself. So that's one of the major downsides for JavaScript. So overall, the issues with the current state of animation on the web is all these different APIs, so CSS, SVG, and various JavaScript libraries. They all have their own idea of what animation is. They all have different conceptual models, and that's more work for browsers in terms of CSS and SVG to implement these different models. That's more sort of duplicated logic. Even though they're not quite the same, they're more or less achieving the same thing. You're just making some value interpolate from one to the other according to some time model. And so if you implement that multiple times, that's not good news for web developers or web browsers. And all these different APIs, it's not nice for web developers to have to learn them all, depending on which they need to learn the pros and the cons and all the different ways to do it. They're quite different. So as you saw, SVG was using the XML DOM, where CSS was using style sheets. These are radically different ways of interfacing with the animation. And if you want to use multiple, because maybe one does one thing, another does another, you want the power of SVG, which has like motion paths and things like that, but CSS doesn't, but CSS is integrated with HTML. You can't fit them together in the same animation. You can't declaratively say that these things will animate like how you would want them to. You have to manually do that yourself. That's not so nice. And this is not a great interface for JavaScript in terms of CSS and SVG, because they just don't really have an API for you to create the animations that you might want at runtime or deferred to the browser to work out. So if you're creating a web app and you're doing all this UI work, you want to make windows pop up, you want to animate things to show where they're moving, this is all very sort of, you need to defer where things should go up until the last minute, up until when the animation starts. That's when you want to decide. And you can't really do that without JavaScript support for setting up these animations.
So, recognising all these drawbacks, so some people from various organisations have recognised there's a need for something better, and that's what we're presenting today. So quite a few people have been working on web animations. Some people from Mozilla, Google, Adobe, and we're working with the W3C working groups for CSS and SVG, and they've got an effects task force, and so all the minutes for discussions are publicly available. Okay, so what are we hoping to achieve? We'd like a common model for CSS and SVG animations, so we'd like to be able to describe them with a common vocabulary. We'd like to have the different animation technologies working together. So it's a huge step forward from what's available today, if we can achieve when it's available. Future animation specs for specific technologies should be able to integrate with this as well. So media integration is we should be able to have animations synchronized with, say, videos and speech starting and stopping, things like that. We'd like to be able to define animations declaratively, but from JavaScript. So we like describe the animation up front and then just have it proceed, and then it should just continue without being tied to the main thread. And so that the main thread might be running some user JavaScript code, responding to events, JavaScript garbage collection, any of those things. But these days our hardware's got multiple cores, even on mobile phones you might have 4 cores, and so there's no reason your animation can't proceed smoothly just because your main thread's doing something else. And we're hoping to help retire Flash, and like HTML animation should be a compelling alternative to Flash.
All right, so here's a simple example of the API. This is, if we execute that, it does it. So that's just going from whatever it is to setting the transform to be a rotation of 360 degrees over 2 seconds. And if we just get a bit more complex example, we're putting some more timing information in there. So we want to iterate that 4 times, do it 4 times, and have an alternate direction every second iteration will go backwards. So that's what we saw there, forwards, backwards, forwards, backwards. And we can give an infinite number of iterations. We can put easing on it, and we can change the playback rate. There's a whole slew of ways you can manipulate the time of the animation through this declarative approach. So it makes it fairly powerful. So it doesn't really matter what the animation is underneath. It will still abide by these modifications. And so that was fairly syntactic sugar, the element.animate, and give it the properties that you want. That's syntactic sugar for telling the document timeline you want to play a new animation on this element with a keyframe animation effect, which is equivalent to the CSS keyframes, which is just, this is also somewhat syntactic sugar to say, let the last keyframe be transformed 360 degrees. The first one is left unset, so it will just grab whatever the values are on the element at the time you play it. And then the third parameter, where we had 2 for the duration, we expanded that to a whole slew of other things. So 2 is just syntactic sugar for duration 2. So if we play that, it's the same thing. Okay, now often you have multiple animations that you can run either concurrently or sequentially. So this is an example of concurrent, so a parallel group, which you just type as par group, and we've got, say, defined 3 animations, and we want them to run concurrently. So all we had to add was new par group and put the animations in an array. So apart from that, it was very similar to what we had before. If you wanted some sequential animations, and just use a sequential group or sec group, and again just define the animations that you want running sequentially. So, but the animations, you don't need to have it like an array. You can have a whole tree, and of some things running concurrently, and within that some things running sequentially, or sequentially, and within that some things running concurrently. So,
So we went from sequential to parallel, and it nests arbitrarily. And so here's the code to achieve that. So we just replaced the middle animation with a group. So that's all fairly trivial to use.
So we've just been showing CSS animations, and this is an example of an SVG animation, simply a path animation. If we look at the code, we've got an SVG path defined here, and instead of using a keyframe animation effect, we can use a path animation effect and give it the data, give it the property to auto-rotate as we see the ball's rotating as it moves, and it behaves just the same. So it uses all the same syntax in terms of modifying the timing. All we did is change the effect that was applied on the element. Everything else is all the same. You can nest this just like everything else, even though it's SVG now instead of CSS. And in addition to creating these animations, when you call document.timeline.play, you get back a player. And a player, see on the mouse move event, what we're doing is we're setting the current time of the player according to the X position of the mouse. So this is the same path animation. We're just controlling where in the animation we are based on the mouse position. So just a random JavaScript call, we can set the player's current time to whatever you like. And going on with the sort of various effects you can do, you can have a custom effect. So here, we've got an animation, we don't give it a target because we're just going to call this custom animation effect, and then what that receives is a time fraction, an iteration, and the target, which we're not using here. And so it's just printing out the time fraction that the animation model is giving it, and the iteration. So that way you can hook up this animation system, all this timing logic, which we see here, into whatever effect you like using this custom binding. Maybe I should take this one?
Yeah.
Okay. So this is a diagram of the timing model that the web animations specification defines. And this sort of shows how the timing is separated from the effects. So these animations we see at the bottom, they are what actually tie the timing model to the actual effect that the animation will have on your document or whatever you like on your JavaScript. And so all these animations, you see these arrows pointing up. What that means is the time at which the animation is, like if it thinks it's at 0 seconds or 10 seconds or something, is dependent on its parent time. So this is the whole nesting, how you can group them and nest them indefinitely. They always look to their parent to say, what is their parent's time? And then manipulate that based on these timing inputs. So whether it had a duration, whether the playback rate was set to something other than 1, and the direction and how many iterations, all that sort of transformation of the time occurs based on what your parent's time is. And so that you could think of the time filtering down the tree and into the animation to find out which time fraction and which iteration the effect should be at any given point in time. This is pretty much a stateless data structure, which you put in a time from the top, filter it all the way down, and you get your effect times. And so this is basically all the different things that you can define for the timing input. We won't need to go into detail into it. It's just showing it's quite elaborate. And so let's scroll. So that's just an example of how it gets calculated. Implementation.
Sure. So just explain where we're up to in terms of the development of this web animation technology. So a specification, Java specification is available and people are reviewing it. We'd welcome feedback from any of it, so take a look. In Chrome, we've been starting to implement, so we've been re-implementing CSS transitions and animations on top of the model that we've described. And so this is basically seamless for end users, so they won't have noticed, but we've basically, instead of having a separate animation engine for CSS transitions and a separate animation engine for CSS animations, we've retired those and just implemented one animation engine that can support both. And we're planning to extend that to support SVG as well. and then we'll be able to retire the SVG animation engine as well. We're working on the JavaScript API, and you'll need to enable a flag if you're using Chrome to be able to use it. So Firefox and Safari have also started work. And yeah, we haven't had anything.
As part of our sort of strategy for pushing this out onto the web, we've got a polyfill, and what that means is it's a purely JavaScript implementation of the API, and that's how we were running it on the slides just now. This is just so that developers can actually use this technology, even though it's not in all the browsers. So because it's JavaScript, it's very much like another JavaScript animation library. You can run it in basically any browser and get the API experience that you want to use. It's available on GitHub, all open source, all patches welcome, everything like that. And what's most welcome is feedback. So if you go to either this link or the git.io/webanim, that'll take you to the GitHub page, and then you can start trying out this API and provide feedback on what you think works well, what doesn't. And let's go to demos.
Okay, so I should point out that right now, because the polyfill is all implemented in JavaScript, everything's right now implemented in terms of one thread. So once the browser's implemented natively, then you'll get all the performance benefits that we're aiming for. But for older browsers, you just use the polyfill and you'll just get degraded performance, but it will still work. So we've got a nice demo here. So this sure. Okay.
So this is a relatively simple example of using web animations to construct a ticking clock. So this is one of those card flipping ones where the thing flips around, changes to the next number. And the code for this is actually quite interesting. So it's a simple set of ticker things which will be filled up by the ticker template that has these slides. If we just oops. So if we look at the clock here, if we actually rotate the clock, unfortunately this computer doesn't have a graphics card, so I can't actually show some of the 3D involved here, but it's essentially using a 3D transform, and I wanted to show that it was actually doing the flip and how it was working in terms of using 4 different faces. But the other interesting thing about this in terms of web animations is when it constructs the clock starts at 0, and what it does to get it to show the current time like it is now is it just sets the animation time to the current time based on Unix time and subtracting for time zone differences. That's all it needs to do to get it to show the current time. So it's just an infinite animation, indefinitely ticking away. And so you can just seek it to the current time like that. Yep, that's about it.
Yep. So yeah, we're welcome for questions.
So with that JavaScript polyfill that you have, is the performance of it on browsers like Chrome good, or is it still all? It's not like a ship that just exposes the Chrome implementation.
Well,
Repeat
the question.
So he's asking if on Chrome whether the polyfill has decent performance. Is that right? Yeah. So performance is a concern that we're focused on in the polyfill. I mean, people aren't going to use it if the performance isn't that great, but we're never going to expect the performance to be as good as a native implementation. And it's really to just tie over the other browsers as their implementations lag behind other things like Chrome and Firefox as they're actively developing it, so that you can still be cross-browser compatible. And by having the polyfill not quite as good as a native performance, it sort of gives the other browsers motivation. If lots of websites are using this technology and they're using polyfill for browsers that don't support it, it'll be slower on those browsers and faster on others that do support it. So it's kind of a win in that sense.
Yeah, maybe we should try the butterfly when that's. we have a demo that I think shows pretty good well the performance that we've got.
Okay. So this is a demo constructed using web animations, all sort of real-time butterflies going all over the place. It should look a little bit better than that because this is running on a Linux laptop, which doesn't have the best GPU capabilities, but you should see the butterfly wings flapping and everything.
Yeah, so on other hardware, it looks quite spectacular, even though we're implementing it in JavaScript and making it's all running on the one thread.
The fact that it doesn't look as good is more a limitation of the CSS implementation rather than web animations.
I think particularly on mobile phones, then our JavaScript implementation will struggle to keep the frame rate up. And that's where the native browser implementation will become more important. I think like desktops have performance to burn.
Yeah.
So,
Yep.
Oh.
so something that I see is that probably a lot of the people that make animations would like to use a tool like Flash to generate them because it's a nice GUI and they can build it in there.
Mm-hmm.
What tools are you providing the people who actually want to do the animations which are not programmers?
Yeah, so I don't think we can really announce too much, but people are working on tools. So
Yeah. If you happen to know of the Polymer project, it's another thing that Google is very much backing is sort of components in the web, very like modular widgets that you can just put on a web page. We are working to make Polymer components that work on web animation and allow you to construct web animations in a sort of Flash-like way. Yeah, so it's something we have identified and we are working with. Okay.
Any other questions? No? Okay. Well, thank you, Alan.
Thank you.
And Eric.